So this is what life is today. Can't get anything done anymore, and this video is probably going to be shot in a bunch of parts as well. Primarily about this, but I've done a whole bunch of stuff in the meantime. I have never really gone away, I just don't have time to make any videos. So before I get to this, I'm going to run through just a couple of the other things that I've been working on. And the primary thing that I still work on today is really 7-inch, because it's such a problem to get a 7-inch to fly well. Yes, you can get a 7-inch to fly well. Lots of people have wonderful flying 7-inch crafts, but as I will explain through this video, there are a number of issues that make me just not want to fly a 7-inch at all, and there are some problems with 7-inch that persist that make it really kind of annoying, and I prefer to fly 5-inch way more than 7-inch for really any reason. So this craft, I was trying to do something kind of spiffy with it. The design is intended to be used with this string, and this is actually a Kevlar string, and the idea behind this was to put tension on the arms such that they're in flexure, and you reduce, I'm looking to reduce the low wobbles. So when you have arms that are longer and props that are bigger, you start getting some wobbles in the frame and whatnot, which make it really annoying for the flight controller to do what it does. Software is fantastic, incredible today, but still it could be improved if the wobbling was improved. And as you go bigger, the arms kind of wobble more, and it's more of an annoyance to figure out how to manage all that in software or in hardware or whatever. Anyways, these Kevlar strings, they actually did work. They work really well, but they're really inconsistent. You do have to tension them appropriately to actually get it to function right. And I mean, if you put like a tensioner somewhere in there in the middle, it could improve it substantially. But the other weird thing was that it would be inconsistent in different temperatures, which didn't totally make sense to me, but regardless, it's too finicky for me to continue even looking in this direction. Good concept, interesting, actually did work, probably not going to be useful on a kind of a typical daily basis. I'm looking for something or things that I can use in a professional setting without any fuss, that just work all the time. So this design went out the window, and there's a bunch of other ones in that respect as well. So this is my attempt at kind of rethinking the concept of a Cinewhoop. This is my primary Cinewhoop. I fly this this is my second most frequently used craft. My first most frequently used craft is going to be this guy, which has some new things on it, and it's just awesome. It's just incredible what it does now. It's been torn up, but that's my primary craft, and then this is really my secondary. And then 5-inch, I don't fly in many areas where 5-inch is really useful, because I'm either chasing really high speed things that I need to maintain speed on, or going after really slow things, so I need something very slow. I haven't really moved into the super tiny kind of a Cinewhoop setup yet. Anyways, the idea behind this was to switch to coaxial 5-inch props to improve the yaw, as well as try to get some added efficiency, although I don't know how much efficiency is going to be added from the fact that you have all these arms and spars and everything in the way, plus the coaxial aspect of it will reduce the overall efficiency of any pair of 5-inch props by 20 to 30% right off the bat. This will work according to a number of people have consulted on, but I just haven't gotten around to finishing it. It's been a while. I will put it together and finish it at some point. The weight is actually right on par with the 3-inch Cinewhoop. I do have designs for duct guards for the outer stabilizing props, but you know, stay tuned. Maybe down the line I'll have something there. I have tons of other things. Okay, so let's get to this guy and just talk about what I'm trying to do with this. So this frame over here, this is using 2809 motors that actually have, these actually have split magnets in them. So the interesting thing about these particular ones that I have, which are just testers, the actual one that we sell in the store don't have these, because I didn't really find a whole lot of benefit. So if you look, there's actually 2 rows of magnets inside this bell. And this is a concept that is shipped on the 25mm motor, and it still is in use on the 25mm motor, because it actually does work really well on that. But as you go bigger and narrower and whatnot, you're supposed to have some effects here and there, but we just didn't find them. I'm still waiting on for Ryan Harold to give me actual bench testing results on this. Anyways, this is the 2809 motor, and this has some effect, but really not enough to bother with. And you do get an even softer high end on the throttle, so it's just something that we just never bothered with. Anyways, let's move on to this craft over here. So this craft over here, a couple things I'm trying to do with this craft. I'm testing a whole bunch of things at the same time. So first and foremost, the overall concept of this angular kind of flying at a 45-degree angle. The arms are set at 45-degree angles. This idea is pretty you could tell yourself, I'm trying to reduce the overall drag in a forward flight stance so that like this, you're kind of like blasting the body into the air. If you're more like this or even tilted up a little bit, the body might even act a little bit like a wing so that you get a little bit more lift. And the idea is to try and get efficiency at cruising speed. That's the hope, that's the dream, that's the plan, that's the goal. Let's see if it actually happens. On that same note, I actually had the manufacturer give me some 1300 kV 22.6 millimeter motor stators. The goal here is to have undersized motors for the prop size and the craft size so that you gain the efficiency of having smaller motors. So big motors are fantastic for performance, for power, for all those things, but they lack in efficiency. And let's talk about efficiency in general right now, because it's a loaded term. Efficiency is based on how you define it, not particularly just flight time of some sort, because you can get more flight. I do get more flight time out of a 5-inch, but you can cover more ground on a 7-inch. So the idea here is that which one is more efficient? If you're looking to cover ground, then the 7-inch is more efficient. If you're looking for flight time, potentially the 5-inch is more efficient. Yes, you can just hover a 7-inch, probably longer than a 5-inch, but that's not what I'm talking about. I'm talking about actual use, actual cruising, actual workload. So if you, again, redefine efficiency, let's look at a craft that can do 250 miles per hour versus a craft that only does 100 miles per hour. Well, if your goal is to go 250, then the 100 mile per hour craft is 0% efficient, while the other one is 100% efficient based on that metric. Now, if we're just looking at flight time or cruising speed, in the 7-inch category alone, I'm looking to improve both flight time and cruising speed. And that's the efficiency goal that I'm looking for on this craft. So flight time is going to be improved by the smaller motors. Efficiency and cruising speed will hopefully be improved by the angular body and hopefully reducing drag in some respect, although it's very hard to tell what is and is not actually draggy. When you put the battery on top of this thing, it's going to be a different animal entirely. Nose is set at a negative 15 degrees, so it makes the overall craft with the camera that would go here about 30 degrees. And so that's that. And then the other aspect of this thing is hopefully going to improve is vibrational resonance and whatnot. I've tested H-frames a lot, and it's really hard to tell what exactly is going on with vibrations and resonance. But the concept or my idea, my theory is that the twisting motion on the arms, which is very, very minor, but causes a load of problems inside the craft, is one of the most significant modes of movement of any kind of resonance on the craft. And so when you have an H-frame like this, I'm guessing, I don't know for sure, you get the twisting motion going down the arm and it's 90 degrees removed from this spar, so it's not really going to travel down this spar. It's making the body go up and down rather than just twisting it and going directly into the body. That's a guess, again, not confirmed. Also, having two motors across from each other may kind of sort of cancel some of the vibrations out on themselves, or it'll get some crazy complex stuff and it'll make everything even worse than it actually is. I've tested this H-frame kind of concept on 5-inch and Cinewhoops, and I found mostly improvements, and some one design had a negative, which I couldn't really account for. But yeah, that's my theory. I use a lot of finite element analysis. It's just really tough to get code to simulate reality to the point where you can actually make predictions off your own code, off the actual simulation. So it's helpful, but it's definitely not absolute. I cannot get it to mimic everything I'm seeing in the real world to a T. So there's something to be said about that. That's why I build so many things and I test so many things. I've got piles of frames, piles of motors, just to see what is happening and try to learn and understand what may or may not be happening. Now, this design I just threw together, and I'll take it apart and kind of show you the features and the things that I do on design to try and get around some challenges, you could say. I don't use tube arms. Tube arms have been shown to be a mess because they don't stay put, and they don't stay put in the angle you set them at, so that doesn't really function. I like using carbon, just plain, flat, normal carbon fiber. The MADD Carbon Company is really, really good at making carbon fiber sheets, and there is very high quality carbon out there that can be used. However, it's very expensive and not really worth the benefit in my opinion, because the cost is 5 times more, and the improvement is maybe 20 to 30% more, which is significant, but probably isn't enough to justify the cost. So I aim to do my work more in the design rather than in the magic materials that I'm going to be using. The carbon you get out of the manufacturers that make carbon these days, it's actually pretty decent, pretty good, definitely not the best. So I'm going to take this thing apart real quick and just show. So when I take the top plate off here, you see this cross plate over here. So the concept of this cross plate is that the carbon on it is cut in the opposite direction from the main body plates, so that it actually has torsional or flexural stability in this direction. This direction, if I was to fold it like this, it's very weak, but it has it in this direction so that it resists the twisting motion of the overall arms and the frame twisting like this. Underneath, there's another one as well. So when the whole thing is together, it's super stiff. And if you look at the construction of the design, you got 10mm arms over here connecting these two. These are a little bit longer than they need to be. They can be a little bit shorter. And then I came up with about a dozen ways to attach this beam to the actual main spar. But this one that I went with, it's not very good. So this is what the piece looks like. It's just a piece of aluminum. It's 7075 aluminum. It's just got a little spar in there that goes fits into this, and there's two on either side to hold it in. It's the simplest design I could have come up with, and it's really just for testing, because this is not as secure as I want to be. There's a little bit of flex in this direction, as in you can just bend, as in it's not even super tight on there. It can just kind of slide a little bit, because the channel I cut for this is a little bit bigger than the actual spar that's in the aluminum piece. Overall, it's probably not going to hold up to a whole lot of punishment. I've already come up with a way better design. Somehow I feel like I need to see the design in real life, in person, to be able to come up with a better design in the digital world. So get into the meta glasses now so that you can't see as sharply. But anyways, so this is let me get rid of this. This is the current one that I came up with, and I haven't even tested the thing yet. But this is one main spar that goes all the way through. I had to design the end of this so that you can slide this 3mm plate on, and once you get it on, if you get forces going this way, it actually pushes on this plate, which is up against these standoffs, and hopefully the thing doesn't fall apart. As in, these are the way I think about the forces and the way it's going to feel forces in an impact. Of course, the just general concept of an H frame with this 90-degree joint here already puts this design at a substantial reduction in overall strength. So this is not going to hold up to a whole lot of just torment and punishment, but that's really not the point. If you're flying this thing, you're probably not crashing a whole lot, maybe a tumble here and there. It's definitely going to hold up to a tumble here and there. I still try to make the design as robust and lightweight as possible. The most significant downside from this design to this design is that I actually got rid of the middle platform in the middle. So there's 3 platforms for mounting electronics in here. I got rid of the middle platform, and by doing that, I could actually shorten the whole body, and it made it a lot lighter. Also, something you'll notice about this craft is that the way it sits like this on the table on a flat surface, the props just spin. They just spin, they just graze, almost graze the table, which means that you can take off and land like this, which is great. If you shorten the back more, then it's gonna sit more upright and it's gonna make it easier to take off and land. Or if you kind of flip over, you can flip back over. That's also a significant concern. I picked 45 degrees as just an arbitrary angle. If you have any other questions about this design, please let me know. Overall, I'm trying my best to come back and do more stuff in this area. I do a lot of things in a lot of different markets that I just don't share with anybody. I've been through quite a trip the last several years, and I think I'm gonna try to be at CES this year. So I am just making this video because I've had so many requests to just make something and put out something. If you have any ideas or anything that you would like me to cover or like me to do, please let me know. I have a lot of things that I'm interested in, but that doesn't mean you're necessarily going to be interested in it. So I'm open to seeing what you guys are interested in general. I'm going to be at CES most likely. If there's anything that you'd like me to cover in particular, please let me know. and talk to you guys later. Bye.